I can go ahead and share my screen. So what I did was I went through the exercise and developed the codes for it. I was hoping that we'll go like exercise by exercise and discuss anything that seems relevant or any problem that any one of us was stuck at. Does that sound okay?
Sure. Thank you.
All right.
Hi, Arnab. I just have one request. Can you please increase the font size of your code? I'm not able to see it clearly.
Yes. Does anyone know? Okay. Should be there.
It should be in tools, global options.
Okay.
Yeah. Global options.
It's global options. Okay. So tools, global options. Okay.
Yeah.
Code.
And I think display. Check on
Display.
Yeah.
It should be in appearance, I guess.
Appearance. Okay.
Yeah. Appearance.
Yeah.
Yes.
Yeah. Does this look okay?
Yeah.
Yes. Thank you.
Awesome.
Thank you, Arnab.
Sure. And what I can also do is have the problems in toggle so that we can go through them. Just give me a second. Yeah. Okay. So shall we start?
Sure.
All right. So the first chapter, the first section was about creating a ggplot, and the first question of the first exercise is run this thing. What do you see? So let's quickly keep on doing that. So we see a empty plot. So this has basically loaded the data in ggplot, and since we have not specified any x or y aesthetics, it's not it's practically creating a blank canvas for us. Then it asks us how many rows are in MPG and how many columns are there, so we can use the n row, n call, or the dim functions to identify that there are 234 rows, 11 columns. Then we have what does the DRV variable describe? Read the help MPG to find out. We do that and we find that DRV is the type of drivetrain. F is front wheel, R is rear wheel, 4 is four-wheel drive. Please let me know if I'm going too fast or too slow, or feel free to interrupt at any point of time. Then we have make a scatter plot of highway versus CYL, which is the number of cylinders. So we start with ggplot, pass on the data set MPG, and then we add a geom point and mention that the x variable is highway and the y variable is cylinders, and that basically gives us something like this, where highway is in the x-axis and cylinders is in the y-axis. The next question, I believe, is what happens if you make a scatter plot of class versus drive? Why is the plot not useful? So let's plot this, and what we see is class is a categorical variable. It has several levels starting from two-seater, compact, mid-size. Drive, as we saw, was the type of the train. It is like a full-wheel drive or front-wheel drive or rear-wheel drive or four-wheel drive. And what we see is that a lot of points are overlapping here. So in order to fix that, I used the position equal to jitter argument, which kind of spread it out quite nicely, and that gives us a lot more information. So that was the first set of exercises. Any questions here or any comments? Anything that we could have done differently?
Hi, Arnab.
I just want
Yeah. Hi, Ronak. So nice to see
Hi.
you.
Okay, so I have one question, not specifically for you, but anybody who can answer. So for example, the problem 5 that you have mentioned, right? So in which you mention aesthetic in geom point, correct? But there is also another way. For example, you could have the same plot if you have aesthetics as you define it separately. So for example, ggplot mpg plus AES.
Plus what?
AES
Uh-huh.
and like for example class drv x equal to class y equal to drv and plus geom point,
Oh, yeah.
right? So this I guess would give the same plot. So like
Yeah.
I am confused, like what are the benefits? In which case should we use the previous line, or in which case we should prefer this one? So I'm not sure if there is any difference or not, but yeah, these are like two ways to do the same thing.
Yeah, you're right. So I think, so from what I understand, when we pass on the aesthetic functions within ggplot, as in the second option here, it's kind of a global setting. So any geom that we provide in the future, it would use these two aesthetics of x equals class and y equals drive. So that is, I think, so depending on our chart use, I think we might want to pass on different. So if our next geom is going to be, say, whatever, geom bar or geom histogram, and we want a separate set of x's and y's, then we might not want to pass, or might not want to have this global global aesthetic declared in ggplot. I think that is what I understand so far.
I see. Okay.
We can actually, this is useful. We can.
I think that's what I understand as well. So that's what it does also.
Okay. Actually, there's a example that comes like a couple of problems down the line. I'm pretty sure we'll come to an example which illustrates this very nicely. Shall we keep going through a couple of more problems? I remember I did this in one of the future exercises. Should we keep going ahead?
Yes.
Sure.
Yes, I guess,
Yeah.
Okay. All right. Cool. So the next one is okay. The first problem of the next exercise set is what has gone wrong with this code. Why are the points not blue? Here, the color is specified as blue and it's rendering as orange. So what has happened here is that the argument for color blue has been passed within the aesthetic parameters. When we do that, it just treats blue as a level and assigns a random color to it. Whereas if we want to pass on blue as a color itself, we'll have to specify it outside the aesthetic. So once the parenthesis for the aesthetic closes, and then we specify the color, it then treats blue as a color and not as a level. Hope that made sense. Moving on, which variables in MPG are categorical, which variables are continuous? How can you see this information when you run MPG? So there are two ways to go about. There's several ways to go about it always in R. So one way is to always do help. We can also use the glimpse function in tidyverse, and that kind of tells us, the type of each of the variables. So a CHR means character. I think it kind of specifies the categorical variables with levels, whereas the double variables are helping us identify the continuous variables. So that was the second problem. The third one was map a continuous variable to color, size, and shape aesthetics. How do these aesthetics behave differently for categorical versus continuous variables? So let's start. So there are three aesthetics that this problem is talking about: color, size, and shape. And the problem is to map first a categorical variable and then a continuous variable to each of these aesthetics. So here we again take data as MPG, and when we are working with color, we have identified that year is a variable which is continuous and class is a variable which is categorical or has levels. So the first variable when we run, when we pass on year as a color aesthetic, we see that the different years are plotted with different colors. However, when we do the same thing with a continuous variable, we see that, sorry, with a categorical variable, damn, what was here a continuous variable? I might have done something wrong. No, okay. So when class is when we plot class, or when we pass class, which is a categorical variable, into the color function, it treats different levels of class as a different and assigns them different colors.
Basically, the difference.
Yeah.
The
Sorry,
difference is that when we see when we map the color to a continuous variable, it will keep the different shades of the same color. And if we map the categorical variable to shape or some aesthetic variable, it will treat different colors altogether.
Can you repeat that one more time?
When we map color to continuous variable like year, it will see different not different colors, but different shades of the same color, blue or same color, green, whatever the color be. But when we map the color to categorical variable, there will be different colors altogether: red, blue, yellow, etc.
Yeah. That's actually a very nice way of putting it. So
like a continuous color palette and a discrete color palette, right?
Yeah. So yeah, I mean, as Maulik said, this is like gradients of the same color, whereas when we used class, it used different colors or different color palettes. So that's perfectly right. Working with size, I think we have similar. So I repeated the same exercise for size and shape as well. So with size, I think it assigns different sizes depending on increasing or increasing order of years. But when we do that with a categorical variable like class, it assigns a different size for each of the levels. And what happens with shape, it doesn't work. So when we assign a continuous variable to shape, it doesn't work. I think shape only works with categorical variables, because we need to the way shape works is that we have to have specific levels that can be related, or that can correspond to a class. So that was problem 4. Any other thoughts on the shape, color, or the size aesthetics for continuous or categorical? Okay, I'll move to the 4th problem, which was what happens if you map the same variable to multiple aesthetics. So this was a really cool feature. I did not know about this. What we did here was, again, passed MPG, specified X and Y, and now assigned class to the size aesthetic, and again class to the color aesthetic, and it worked for both of the aesthetics. So it is not only assigning different colors to each of the levels, but it's also assigning different sizes to each of the levels, which was really cool, and I did not know about this. So yeah, it basically works, and I also tried it with one more. So I assigned the class variable to size, color, as well as shape, and it was pretty neat. It kind of did all three. So different colors plus different sizes plus different shapes. So I don't know what we can use it for, but it's good to know that it can be done.
Yeah, that was my question. Like, where do people use this all?
Yeah, I don't know. I don't know why would somebody use something like this, but yeah.
Everything, yeah.
Yeah. Yeah. Nice. Okay, where were we? Okay, what does the stroke aesthetic do? What shapes does it work with? So the hint was to use geom point. We did that. And basically stroke is kind of a border. So what we can, I mean, I think it would be clearer with an example. So here we pass on, we specify the class variable as size. Now class was a categorical variable with levels. So it got like different sizes corresponding to different levels of class. But the stroke variable is basically kind of a boundary, I guess, which is when we increase its value, it makes it thicker. I found a useful example, I think, down in the help file, where once the aesthetics were specified, we can go on to mention, a shape, a different color, a different fill, a different size, and a stroke, and it kind of makes for really interesting graphics. And we can play around with this a lot too. So different shapes can be assigned to it. Color, of course, can be changed. Fill can be changed too. And yeah, the stroke basically is the outer layer from what I could figure. But if anyone can throw more light on this, that would be lovely.
Thank you, Arnab. Even I was so confused with stroke when I was doing this chapter, but I think now it's more clear. Yeah.
It's kind of a boundary, right?
Yeah, it just makes it thicker, is what I feel.
Yeah. The more, I mean, the higher the value, the thicker the boundary becomes. But yeah.
Then is it not similar to size as well? So for example,
yeah,
size
I even get
does the
confused
same
with that.
thing.
Yeah, let's play around with both. Yeah, I think it's very similar. How can we so the size here is the, if you can see the little dot, little whitish dot. Let me actually make it white. I don't know if this helps at all, but I think that the little dot in the middle has got to do something with the size. So the size, when we increase the size, the central white portion increases or decreases, if we notice.
Yeah,
stroke,
I can see that.
Yeah, stroke kind of changes the outer edge. So I think in geom points or in geom objects, there is a core area, and then there's a like an outer boundary area. The core area is the color of the core area is corresponds with fill, whereas the color of the outer area corresponds with color. So yeah, I don't know if that helped at all. But so color and stroke, I think, go together, and size and fill go together. Does that make any sense at all?
Yeah, I think that's what it's doing now.
Yeah.
Whatever we've seen.
Yeah.
Can you repeat again? Like, sorry.
Yeah. So I think what I think is that there are two regions for any geom object. One is a core region, which is its size we can control by the size argument, and its color is actually the fill argument. And then there's an outer area or an outer region. Its thickness is determined by the stroke argument, and its color is determined by the color argument outside the aesthetics. So let's go through it one by one. So let's try to play with the core region first. So I'm kind of minimizing the outer edge right here. And we are saying that the core is going to be red, and it is going to be of size 5. That did not work, so my hypothesis here fails on its face. Try one more time. Nope, does not work. Nope.
Okay, I actually
Can we
found
have a
one
different
example.
shape?
Yes,
Yeah.
Go ahead.
I've just pasted in the chat an
Uh-huh.
example. I think this clarifies the difference between stroke and size. If you could copy it from the chat on Zoom.
On it. Aditi, you were saying something.
I was just thinking that is it because of the shape, the triangle? No. I think let's try what Ronak is saying.
Huh. Okay, so sizes has 16 variables. So size and stroke. Okay. Where were we? Huh. So ggplot, we have sizes. Let me just plot the whole thing first.
So if you see, the size is determined, the red part which we are seeing, I think that is what size decides, right?
Yeah.
And the black border that we see,
Yeah.
what stroke does, it basically thickens the border, I guess.
Yeah. I also had the same sense. I don't know why I could not alter the.
Probably using a round or like a circle would be better. I don't know that or.
Maybe. Yeah.
Because I also felt that whatever you're saying is right, because this is exactly what you were saying, right?
Yeah.
I think it was pretty clear with the triangle shape which he showed. It reflected the same graph which Ronak shared. So.
Yeah. But anyways, I
Yeah,
mean,
we can try.
Sorry.
Yeah, we can try it again just to get more clarity on that.
Yeah. Okay. So I'll try this one more time. Oh yes, it worked. Okay. So so when we change the fill to red and the size to 5, it changes the inside of the core. So now let me say we want to increase the size to 6, or just for kicks to 12. So the size of the inner core increases. However, the outer boundary, which is the color black, it remains the same. Now, when we change that, just to highlight, I will use a different color here. Colors and try to increase this. So yeah, that's so the green portion remains with a smaller size of 2, and then we have stroke determining the outer edge. Interesting. Yeah, I think both these examples. This actually is very
Thank you.
Yeah.
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 Thank you, everyone.
Awesome. Thanks, Ronak. And then, yeah, that was the last exercise of. Oh no, there was one more.
I just have a small question. So can anyone tell me a practical application of where we'll be using stroke and stroke for our graphs? If you can tell me how will it be useful for a better database?
Can I just pitch in? Like,
Sure.
I think one of the main thing is that to make it look good. If you have if you want to make it look inside of it in a translucent color, or have alpha very low, then
Yeah.
you come order, and then just to look, and then that way you can show the edges of what your position is and the one below it also. So just an example. Not loud, yeah.
Okay. Okay.
Yeah, I have used it for
So
that
it
reason. I don't know if
all
anybody else.
right. Okay. Okay. So it's basically for the aesthetics of the graph, just to make it more appealing.
Yeah.
Okay. Thank you. Yeah.
Nice. The next and the last question for this set of exercises was, what happens if you map an aesthetic to something other than a variable name, like aesthetic color equals display less than 5. So I did that, and what basically happens is when we use something like display less than 5, which is a logic statement, it treats it as a true and false, and once the true and false so after assigning true and false to the data, it colors true and false. So it treats the newly created variable as a categorical variable, and colors the trues and the falses differently, which is also which could be a quick way to. So this is really good data visualization exercise. So we can quickly kind of segregate different data sets based on operands like less than equals or greater than or equal to or something like that. This was very interesting too. Any comments on this? All right, I will go to the next exercise, which was 3.5.1. Okay. The first question was, what happens if you facet on a continuous variable? So yeah, let me just do not remember. Yeah, so cylinder was a continuous variable, and we were CTY was a continuous variable too, and when we plot on that, so what it does is, for each value in the variable CTY, it creates a new facet, which basically ends up creating a lot of facets for the plot. So that's why it's not advisable to use facets on continuous variables, because if we do it, depending on how many values that particular variable has, it would create one facet or one grid for each of the values in that variable. So that's what it's doing. The next question was, what do the empty cells in the plot with facet grid? This is the plot right here. So what do the empty cells in the plot mean? So when we plot, there are several grids that are empty. What this basically means is that these cross sections don't have any data in it. So if you remember the second cell in the top row was empty, and then the bottom 2 rows were empty. And when we do a cross tabulation of these two, we see that they do not have any values in it. Just to show this again. So the second cell in the top row and the last 2 cells in the bottom row were empty. And as we saw, they had no values in them. The next part of the question was, how do they relate to this plot? I don't think I understood this problem. So what do the empty cells in the plot with this one mean? We figured that out. How do they relate to this plot? And this is the plot right here. Was anyone able to figure this out? I could not. I don't really understand what the question is trying to ask. How do they relate to this plot?
They just plot DRV and CYL like a scatter plot, and then they didn't have. That's what I understood. Am I thinking wrong, or
no? What was it? I didn't understand.
It's just a scatter plot between CYL and DRV, and wherever there is no point, like 5 and 4, CYL 5 and DRV 4 don't have a point, right? And I don't know. This is what I thought and went ahead, and I also looked at solutions. So
okay, no, that makes sense. Yeah. Okay, yeah. So you mean okay. No, I get it.
One of the ways to think. I'm sure others will know better.
Yeah. Oh, so instead of doing a table like this, I mean, we could also have done something like this. That's what it is.
Yes.
Okay.
Yeah.
Fair enough. Yeah. Got it.
Please stop me if I'm correct. I'm just thinking out loud of whatever I feel.
No, I think that made sense. Made total sense. Any other thoughts here, or should we move ahead?
Actually, you are right. And even in the earlier question, when we are mapping, we are faceting on a continuous variable, every value of that continuous variable becomes a level of factor. For example, when question 1, what happens if you facet on a continuous variable? That happens. Every value becomes a level in the factor. Now, continuous variable becomes a categorical variable in this case.
Exactly. Yeah. That's right. This is absolutely right. Every value that the continuous variable has, that has become a label that is seen in these gray boxes on top. So yeah, that makes sense. Now, continuous variable is being treated as a categorical variable. Perfect. We move to problem 3. The third problem said, what plots does the following code make? What does the dot do? So they had 2 different plots. This was the first plot where the facet grid had DRV tilde dot. So this essentially creates a grid with factors of DRV or levels of DRV in the rows. And when we have the dot before this tilde function, I think it flips coordinates, and the levels of cylinder, the variable cylinder, appear in columns. Is the difference clear?
Yes.
Yeah.
Cool. So depending on whether we want the levels to appear in columns or rows, we might want to have the dot before or after the facet variable, basically.
No.
So should we go ahead?
Yeah.
All right. Problem 4. This one had 6 problems. So take the first faceted plot in this section. What are the advantages of using faceting instead of color aesthetic? What are the disadvantages, and so on? So this was the set of codes that they used, and the question is, take the first faceted plot in this section. What are the advantages of using this instead of color? So this is the plot that we get when we use the facet wrap function. I tried doing the same using color. Now the difference is that when we use color to plot class, what is happening is it's creating just one plot where all the points are plotted and the levels of class are displayed with different colors. The advantages of using a color aesthetic over a facet is that it just uses one plot, so we do not have to look into multiple grids to identify what's going on. However, this might get very complicated. So in facet, if the question, for example, was that we are trying to understand the relationship between display and highway, and we want to do it, we want to understand how that varies with class of the car. We might want to facet it rather than color it, because we want to get into the get in depth of this association between highway and display for different levels of class. However, if we want a top level overview and we do not want to know, I mean, we do not want to get in depth of what is happening in class, I think we might use color. And another disadvantage is that with larger data sets, when there are a lot of points in a particular variable, there would be this plot would be like very crowded, and it would be really difficult to ascertain any sort of pattern based on colors. Any other ideas on advantages or disadvantages, or when to use facet over when to use color?
For facet, I usually use when the levels are too less, and can be included somewhere. And I usually use color when there are many levels. Yeah, that's what I do.
Yeah. That's also one of the factors we should keep in mind. If there are too many levels, I think there would be a lot of facets, and that would also lose interpretability. Nice. The next question was, read the help for facet wrap. What does nrow do? What does ncall do? What other options control the layout of individual panels? So nrows and ncall, I think we used it here. Determine the number of rows in which the facets would be spread out. So for example, if we change this, it would be spread in 3 rows. And we can also specify ncall, which is this would work. Which determines how many columns will be there in the overall grid. And then there are a lot of other features that go and help us determine the aesthetics of the facet. Some of them were so one of that was scales, which is a really important argument. So scales could either, so it's fixed by default, which means that every little cell in the facet or in this plot will have the same set of x and y values. So for example, in this plot, we have the x's ranging from 1 to 7, and the y-axis ranging from 0 to say 60, 50. And that does not change. That remains the same for all of the plots. However, if we change this from fixed to free, each cell becomes independent. and the X and Y values for each of the cells are determined by how their points are laid out in the Cartesian coordinate. So depending on, so for example, the first cell right here has very sparse values, and it does not have a lot of values in the x-axis which are less than 5. So it starts from, say, 5. Whereas the other cells had values which were, which started from, say, 0, and they ranged from 0 to 7. Similarly, we can see that the y-axis is also very variable, and that depends on how the y-axis are spread for each of the cells right here. There are other parameters that are also useful. So dir was very useful. So dir is direction, which could be either horizontal or vertical. Horizontal is the default. So we can yeah, so this is a vertical arrangement versus a horizontal arrangement. I don't know what exactly changed. Oh, I see. In the vertical arrangement, we have two-seater, compact, mid-size, minivan, pickups, subcompact, and so on and so forth. Here it is, so two-seater, compact, mid-size, minivan. So rather than being vertically, so this is vertically arranged, where each of the levels appear one on top of the other. In a horizontal layout, each of the levels of the class variable are arranged from left to right. So that's another difference. Any other interesting, facet parameters that we know of?
I do use a couple of them. So for example, you can use labeler, which is there to, give label of the title of the facets maybe. So for example, what you see as two-seater, compact, mid-size, right, on the top of each facet name, you can change that with labeler function using, but that's not straightforward. So maybe you need to pass a function basically, and based on that, it shows the output.
Okay.
Another thing is also, a small change is strip position, which we can use. So where do you want to show the labels basically of each facet? By default, it is top. But we could use any top, bottom, left, right.
That's interesting. Oh, wow. That's cool. Yeah, that's pretty cool.
Sorry to interrupt, Arnab. Arnab, can you explain? I'm sorry, I think I didn't hear that labeler function. It seems very useful, but
okay. So
can we reclass it like in the to avoid this?
Sorry.
Can we reclass, like change the names of like factorize all the names instead of using labeler, or labeler is the only option?
No. So usually labeler, what it does, it changes the names of the facets, all the facets that we have, correct? So, but now using labeler is actually very complicated. Most of the times you don't understand. Like for me, it was very difficult to understand. I still find it difficult to use labeler because we don't know what the input is and how it is being mapped, but yeah, we can do that. Another way is, for example, if you really want to change the facet names, right? So the best way is to change the names of the variable itself before passing it to
yeah.
Yeah,
right?
yeah.
I guess that is the straightforward way. But you can do it using labeler as well.
Yeah, that makes sense.
That means like, yeah, a lot of extra things. Yeah, sure. Thank you.
I don't use this, but I found this reading this drop pretty interesting as well. So a lot of times what happens is that there are certain levels which do not have any values in the data set. So if we specify drop as true, which is actually the default, any cell which does not have any values would be dropped. That could be used sometimes. Huh. That was nice. Why doesn't the facet grid have n column n row arguments? So facet grid. Does anyone know? I do not understand what I wrote here. Why does the facet grid not have n column n row arguments? Any ideas?
Isn't it because they do only one side? Like, I think facet grid just does once row and or only columns. Only facet wrap has both the columns option.
I see. Okay, this is an example of a facet grid.
Yeah, you need to have two variables then.
No, I think in a facet grid we already provide two variables, so it's kind of fixed, isn't it? So in a facet wrap we are providing just one variable, and depending on the level of those variables, it can be arranged in rows and columns. Whereas in
but if you go ahead. I'm sorry. I'm so sorry. Yeah.
No. So I just wanted to say that in a facet grid, we always have to provide both the x variable and the y variable. So
you can put a dot as well. So when you put a dot, you just have one variable and it will be either in row or in column.
Oh, yeah.
And in facet wrap, you can have having just one also, you can have both row and column.
Yeah, but then if we, so why does facet grid not have row or column? I think it's because the number of rows and number of columns are always determined by the number of levels that these variables have. So the user cannot define it. Does that make sense?
Yeah. Yes.
So in the number of columns in this grid will always be the number of columns which would be equal to the number of levels in the DRV variable, and the number of rows would always be the number of levels in the CYL variable.
Yes, perfect. Yeah.
Grid, it's like m by n matrix. M is a number of level in X variable, Y is number of level in Y variable. And each cell in the matrix is a graph itself.
Yeah. And M and N are already defined by virtue of like.
Yes, by the number of levels. They are already defined.
Yeah. Awesome. So that was that. Where were we? The last question was, I think I couldn't. So the last question was, when using facet grid, you should usually put the variable with more unique levels in the columns. Why? I am not really sure. So this is an example where we are plotting DRV against FL. So DRV has 5 levels, FL has 3 levels. When we flip it, it also works. Not sure why. Is there a heuristic of using the variable with more number of levels in columns? Any ideas?
I didn't. When I was reading this, I just thought that it's because it looks clean. That's all I thought.
And I also think that if we put more number of levels in row, I mean, when we make it wider, then probably the default size of the graph will not fit into A4 size or whatever your print size is.
Could be, yeah. Could be. It definitely does not look as good. All the cells are like pretty flattened out. So yeah,
Yes.
and the printing thing could also, I don't know if that makes sense, but yeah, this looks good. I think that's good enough reason. Moving on to exercise 3.6. Yeah. What geom would you use to draw a line chart, box plot, histogram? So we have geoms for each of them. We have geom line, geom box plot, geom histogram, and geom area for area charts. The next question was, run this code in your head and predict what the output will look like. Then run the code in R and check your predictions. So I think let's take a minute's time to run this code in our heads. And I think this is, I have too many lines here. Yeah, so this is what it looks like. We have x-axis as display, I believe. Y-axis as highway, the color being specified by the drive. We also have an additional layer of geom point as well as geom smooth with the standard error as false. So this is what it looks like. The next question was, what does show.legend equals false do? What happens if you remove it? So first we plot a graph with show.legend set as false. So what we see here is that there are no legends that appear. So in the previous graph, if you remember, we had a legend which showed the different types of tribes. When we use show.legend equals false, nothing is displayed. And when we don't use show.legend equals false, by default, the legend is displayed on the right. So that was it. The next question was, what does the SE argument do to geom smooth do? So SE is standard error. What it does is it adds this gray area around our line, which is to assign the standard error around that line.
Sorry, Arnab, I'm interrupting you. How to get the data for this? Like, is there a fortify option? Can we get the data of the standard error? What's in the of the geom smooth of the data?
No, you mean how they calculate it?
Not how they calculate it, but then can we get that data instead of calculating it separately?
Oh no, I don't know.
No, okay.
I mean, I don't know. I mean, anyone else? Does anyone know if we can get the data for the SE?
I am not sure, but can we get it through stat summary function, stat_summary? I am not sure because I have never used this.
Okay.
Okay, I guess there is a way, but it's going to be very complicated. For example, if you save this plot in an object, right, and try to explore the structure, I'm sure the data is present in there, but we have to do a lot of trial and error and find out exactly where this data is being stored.
Okay, I've never had success storing anything as ggplot object and then getting something out of it.
The data is present.
Yeah, it should be present.
Yes.
Okay, thank you.
Let's. Okay, that's a question I think we should explore for our next class. But yeah, this seems that it has a lot of information in it. Okay, let's think about it and maybe connect on this in our next session.
Sure. Thank you.
Awesome. Yeah. So the next question was, will these two graphs look different? Why or why not? This is the first graph, which, yeah, Ronak, this is exactly what your question was towards the beginning of the session. So the first graph is data equals MPG, the mapping aesthetics provided within the ggplot line. Whereas the second graph is the aesthetics being passed on to each of the geom point and geom smooth functions. As you rightly pointed out, Ronak, these work absolutely the same. Both of these create this exact same plot. And the reason is that what we are doing in the second line is that we are passing on the aesthetics individually, whereas in the first case we mention it as kind of a global environment for the ggplot function. So it's both the same. And another thing, if I'm not wrong, what happens is I can so the aesthetics within a geom object overrides any global aesthetic. So for example, if I mention an aesthetic of color to the ggplot line, and within a geom function, I mention a different color aesthetic, the aesthetic within the geom object would override the whatever was passed on in the ggplot line. Does that make sense?
Yes, yeah, makes sense.
Awesome. The next question was, recreate the R code necessary to generate the following graph. So they provided a bunch of, I think, 6 graphs, and we were to recreate that. So the first graph was pretty straightforward. I think we were doing that in the examples above. So it's a geom point plus a geom smooth, and the geom smooth does not have any standard error. So we have a geom point. We can choose or not choose to use or not to use a jitter, but then we pass on the x and the y values in the aesthetics in the ggplot line, and then we add a geom smooth and a geom point object, and we get something like this. Then we have the second graph where we have multiple geom smooths based on drive, I guess. So in geom smooth we can group by drive, and the rest of the things remain same. We do not have a standard error, and this is the kind of graph that we get. The third one was the geom points had different colors. So the geom points had different colors as well as the geom smooths had different colors. So in this particular example, we passed the X, Y, and color aesthetics in the ggplot line, and then the rest of the things remain the same. So what we get here is that the geom points and the geom smooths take 3 different colors based on the levels of drive. That's because we passed on color in the aesthetic above, and then we also grouped geom smooth by drive, so we get 3 different lines by drive as well. Then we have plot D, the fourth plot, which has 3 different colors for drive, but then just one geom smooth line, so it does not have any color. So I think this is the example that we're trying to do to answer your question towards the beginning, Ronak. So here what we are doing is we are using a couple of different aesthetics. In the ggplot, we are just specifying the X and the Y. In the geom point, we are specifying the color as drive. And we do not mention any color aesthetic for geom smooth because we want just one. We do not want to group it by drive. So this is what we get. Next we have the geom points as different colors, but then the geom smooths as different lines. So we use the line type argument here to achieve this. The rest of the things remain the same. And the last one, I think it has got to do with stroke, I think. So we have, it has different colors for the geom points. So we have a geom point, we have fill. I think we should also have color. So the color seems like white here. So I'm going to use color as white, and the fill could be tribe actually, which can be mentioned. This should. Oh. Huh.
How about reducing the stroke? Yeah.
Yeah. Maybe increase the size.
Yeah. I think the fill parameter should be inside the geom point, and that should be given as drive.
Okay, so take this out.
Yeah, and put it inside geom point.
Okay. And mention drive here.
Yeah, probably that is the.
Okay, maybe an aesthetic here. It worked, but then what we want is different colors. I could not figure this out.
I guess we could get different colors. Sorry, yes, Aditi, you can go forward.
Sorry, Ronak. Can we put everything inside AES? Aesthetics, color, and yeah, just thinking. No.
Yeah, it's treating everything as aesthetic.
Okay, I guess if you, in the top AES, if you could write fill equal to drive there and remove color equal to red. So this will give us basic plot, but I don't know how to give stroke colors basically. So if you have size equal to 3, stroke equal to 2 here. Yeah, run this. Why would this size?
So I always thought, that even I think we were struggling with this a little bit earlier as well. I always thought that color would be associated with stroke.
To debug it line wise, can we remove stroke altogether and just see if fill is happening? Okay, so now can we have color as DRV?
Yeah, so far so good. Right, this.
Okay, now let's have stroke, and in geom point, let's have stroke as 1 or something. Okay, so it's just increasing the point.
Can we change alpha level 0.5 or something?
I think, yeah, Maulik, that
I
was a
think
good
we
thing
got
because I
it
think there
right.
is some change. Just
Yeah,
that we
just that
need the
we're not
border
able,
white.
yeah, exactly. We are not able to change the color of the stroke.
Yeah, that is very weird.
Mm.
How about we try in the main GG plot aesthetics, color DRV, and
Oh,
fill also DRV, and
sorry.
then
Can you come again?
fill as well DRV,
Fill DRV,
and color also DRV.
color DRV.
Yeah, just see if
I see
okay.
what is.
Now change the. Okay, sorry.
So I think what's happening is let's retract a little bit. So this was good, right? We are getting the color and we are getting the stroke. Now what's happening is when we mention color as white here, it doesn't work because this color in geom point is overriding this color in
Overriding,
the
yeah.
yeah, exactly. So that's why it's making all the colors white. I don't know how to solve this.
You can remove the one which you don't want. Yeah, you can remove that.
But then how will we make this because here I wanted to say that okay, this color is related to stroke.
Okay, how about we change color D equal to DRV to fill equal to DRV? I think we have tried that just to. Okay, why not override it? Can you put a comma here after color equal to DRV and add fill equal to DRV as well? It's not the right elegant way, DRV, but no.
I think, can you remove the color inside geom point and try it again? Just.
Okay, I'm seeing the solution now.
Yeah, let's do that.
Something similar to overriding, it's asking, yeah, I just pasted something. You have to define geom point again.
Oh, I see.
But they haven't used the stroke at all there, which we thought that we have to use.
Yeah, they haven't used the stroke at all.
They haven't used at all. So, okay. But doesn't stroke makes more sense than what they have used here?
How is their color changing? Okay, let's use stroke on there.
Yeah.
Yeah, okay. It's working. Yep.
Yeah, great.
So I think they had some version of stroke already there. Maybe there's a default size of stroke that does not need to be specified. Yep, this works. Nice. I'm definitely going to use stroke in my next whatever plot I make.
Yeah, definitely. I'm going to try out stroke now.
Okay. Okay, so that was the last one. Let's move on to the next exercise. 3.7. What is the default geom associated with stat summary? How could you rewrite the previous plot to use the geom function instead of the stat function? Okay, so when we go to help for the stat summary, we see that the default geom is point range. And now the question is, how could you rewrite the previous plot? The previous plot was this, which uses the diamonds dataset and then uses stat summary to identify the minimum value for each of the cuts, the maximum value for each of the cuts, and then the median for each of the cuts. So this is how they achieved this graph, this plot. They're asking us to rewrite it to use the stat function instead. So what we can do is use geom point range, and point range, the geom point range comes with a summary stat of its own. And its default value is identity, but then we can provide summary as a statistic, and summary by default calculates all the min, max, mean, median, those kinds of things. So we can achieve pretty much what was there in the previous graph by just using geom point range and using summary as a stat as the stat function. Does that make sense?
Yes.
Awesome. Next we have what does geom call do? How is it different to geom bar? I always had this confusion. Thanks to this exercise, it's more or less clear now. So geom bar and geom calls are two different things. Bar is basically it just takes one x value and then counts the number of times that particular level appears. It does not need two different values. And a good example is in the dataset, in the diamonds dataset, we can just say geom bar and x equals cut. What it would do is each of the it would count the number of times that each of the cuts appear, and it would plot a bar for that. Whereas a geom call is slightly different. It asks for a x value and it asks for a y value that it wants to plot it by. So for a geom call, we would need to say that, okay, these are my so cut is my x value, and for each of the x, I want to plot the values of the price. So that's basically the difference between the call and bar. And another interesting feature is that geom call has a default stat of stat underscore count. Sorry, geom bar has stat underscore count because it's basically counting. And geom call has stat underscore identity as its default stat value. Hope that helps. It was really helpful to me. The next was most geoms and stats come in pairs, and that are almost always used in concert. Read through the documentation to make a list of all pairs. So what I found was that for each of the geom objects that we have, it mentions the default stat that they use. For example, geom line has identity, geom point also has identity, geom box plot has stat box plot, geom histogram has stat bin, geom bar has stat count. As we saw, geom call has stat identity. So that is very useful. Any further insights on this? Anyone? Okay. So the next question was, what variables does stat_smooth compute? What parameter controls its behavior? Okay, so when we see stat_smooth and scroll down a little bit to computed variables, we see that it computes the predicted value for y, y minimum, y maximum, and the standard error. I think, Aditi, this could be helpful. So it does calculate the SE.
Yeah.
Yeah, we will need to figure out how to retrieve it.
How to do that.
Yeah, but it calculates all of these things. And the next question was, what parameters control its behavior? Any thoughts on that? I seem to have skipped that part.
I think it could be controlled by the method used. Is it LOS or is it LM?
Okay. Yeah. Okay, that makes sense. So for example, what is the method that we want to use to calculate the standard error?
By default, it would be LOS, I think.
Yeah. By default, it should be LOS. Yeah. Awesome. That makes sense. The next question was, in our proportion bar chart, we need to set group equals 1. Why? In other words, what is the problem with these two graphs? So let's first see what graph we get by running what they provided. So this does not use the group argument. And what we see is that for each of the values of cut, the proportion is stacked almost to 100%. When we use group, it then kind of plots it by the accurate percentages. I do not exactly understand what the group function is doing. So if anyone can help with that, that would be really helpful. But yeah, this is exactly what is happening. I mean, if, the codes that they have provided are stacked fully, but when we use the group function, it attenuates it to corresponding to the proportions. Any ideas what's going on?
I usually stay away from adjusting it on top of each other, because at the end we never know what happens and what's the exact values. I don't know how to communicate those. So I usually use the normal bar plots.
Yeah. Me too. I think this is just something to keep in mind, that this is a way to get rid of those stacked bars, I guess. Moving on, second last exercise. So what's the problem with this plot? How could we improve it? So this essentially had a lot of overfitting, or a lot of overlapping points in this graph. We could just use jitter to help it to kind of spread it out a little bit. That adds a lot of information. The next question was, what parameters to geom jitter control the amount of jittering? And there are quite a lot of parameters actually. So for example, this is the jitter that we used in the previous example, and now we can provide size, alpha, color, shape, width. So almost all of the other arguments are similar to geom points. So size, alpha, color, shape, everything is the same. The two new things that I learned were width and height. And these two parameters are essentially mean how much. So width means the horizontal distance by which the underlying points would be moved to kind of from the overlapping point. So if we increase the width too much, we'll see that the points under the overlapping points are like very like horizontally spread out. Whereas if we keep on increasing height, we'll see that they get like vertically spread out. So that was something that I so these are two parameters that I learned new, which were interesting. Any other parameters that anyone knows of? Okay, we can move to the third problem, which was to compare and contrast geom, the geom jitter with geom count. The best way to do that is with examples. That's exactly what I did. So in the first example, we use the MPG dataset, plotting city and highway mileages in X and Y axis respectively. We use geom point as well as geom jitter, and this is what happens. When we use count instead, what it does is it assigns two different levels of overlaps. So basically, what jitter is doing is that if there is any overlap of a data point, it spreads it out horizontally or vertically. What count is doing instead is it's counting the number of data points that are overlapping one on top of the other, and then assigning it a size. So bigger a larger size means that that point has a lot of overlap. So larger point in this case means that it has about 10 data points that are overlapping. Smaller circles here represent that there are about 5 points that are overlapping one on top of the other. That was interesting. Moving on, the fourth problem was, what's the default position adjustment for geom box plot? Create a visualization of the MPG dataset that demonstrates it. So I went to the geom box plot help file, and the default position is dodge 2. And then we use the same thing to plot a couple of different box plots, and this was interesting. So first we use a box plot to plot class against highway mileage, the class of the car versus highway mileage. And this is using position equal to dodge, which is the default position. Next, we see what happens if we add a color aesthetic to it. So we have class plotted against highway mileages, but we also have the colors representing the drive of the car. And here, when we use the dodge parameter, we see that the box plots are kind of not perfectly aligned. They are dodging each other, and it's really difficult to read which one of the box plots represent which class of the vehicle. So we can use the identity position here, which kind of overlaps, which kind of merges the different box plots corresponding to one particular class into a vertical, into the same vertical line. So that kind of arranges it a little bit better. However, a disadvantage here is that there could be like overlaps, and one box plot can be like hidden beneath And I think this is the last exercise. So this was pretty interesting too. So the first problem, so this exercise was mostly about coordinate systems. The first one was turn a stacked bar chart into a pie chart using coordinate underscore polar function. So we first create a stacked bar chart using position equals fill. Again, using the MPG dataset, x-axis is the class and fill is also the class. So this is how it looks like. And when we add the coordinate underscore polar, since it's a stacked graph and everything is 100%, it just converts that into a pie chart, which is pretty neat. The next question was, what does labs do? Read the documentation. So labs is basically labels. We can use it to provide X labels and Y labels. And this is a example. So xlab is, this is class. So that's class, and then this is the count. So that's pretty straightforward. We then have what's the difference between coordinate underscore quick map and coordinate underscore map. I do not fully understand what coordinate underscore map does. Coordinate quick map is something like this. So they have a few specific countries, I think. So they have a world map. They have New Zealand, Italy, France, etc. I did not find one for India, but so this is the world map, and yeah, it basically plots the world. I'm pretty sure we can use this as a base to kind of color it or use it to develop a chloroplet map, which shows different countries with different color gradients. So that's what the the coordinate underscore quick map does. I'm not sure what the coordinate underscore map does. The help file. So this is from the help file. It did not work for me. If anyone has worked with it before, please let me know. I don't know how to work around this. Any ideas, anyone, on coordinate underscore map?
Actually, none of them worked on my PC. I don't know what was the problem.
Oh, it worked for you?
Yeah, it didn't work for me.
Okay, I don't know. Anyways, I just picked this from the help file for coordinate underscore maps. I think it's right here. It may be in my computer, or it may need like higher graphics or something. I don't know. The last question was, what does the plot below tell you about relationship between city and highway MPG? Why is coordinate fixed so important, and what does geom AB line does? So let's first run the plot with coordinate underscore fixed and run a plot without it, and then see what's the difference. So when we do coordinate underscore fixed, this is what we get, and it's easy to understand the relationship. Whereas when we remove coordinate underscore fixed, it kind of flattens it out a little bit, so that this line is not that identity line anymore. So that is the difference between using coordinate fixed and not using coordinate fixed. And geom underscore AB line basically helps us in telling, so it's basically a line for x equals y. And if the plots are above x equals y, it has a certain implication, which means that, for lower values of x, y is higher than what it should be. So that, I think, so this graph is helpful, and using AB line is helpful because it tells us that, highway MPG is higher than city MPG in some ways. So yeah, that's what that line does. But any other insights on this? All right. So I think that brings us to the end of chapter 3.
Yeah, thank you so much, Arnab, because I read the chapter once or twice and I still had so much to learn during what you presented. So it was a wonderful session. Thank you so much. I just had one request, can you also in the main GitHub repo of R4ds online community, can you upload these?
Sure.
Using a pull request? Okay, thank you. That's all. And we need volunteers for the next session. That will also be helpful if people volunteer for the next 2 weeks so that we don't have to worry. And what are your holiday plans? And should we stop and then start again? Whatever you think.
I have no plans
I
for
would be more comfortable for model and markdown.
Huh?
Sorry, Maulik, we didn't hear you.
I would be more comfortable doing the chapters on model and R markdown.
Okay, that is chapter number?
Just a minute. Markdown is 27, 29. And models are 23, 24, and 25.
Okay,
so
you want...
stage.
Okay, they are at the later stage. Okay. What about others? What chapters you will want to do?
Yeah, firstly, Arnab, thank you so much for this session. It was really good. As Aditi said, there were so many questions that I had, and all my doubts were cleared. Thank you. And I can volunteer for the next chapter. That wouldn't be a problem. So my doubt is the next chapter is workflow basics, and it's not very descriptive. So I mean, it's just how to code better and things like that. So shall we combine chapter 4 and 5, or should we have chapter 5 in 2 sessions because it's a big chapter? What do you all feel?
I like both the options, Deepti. Like we can combine them and then do half, split them, or however you feel comfortable in.
Okay, so what I was thinking is for the next session, we can have the workflow basics and half of data transformation. And for the next session after that, the entire chapter of data transformation will be completed. Would that be okay with everybody?
Works for me.
Yep.
Okay, great.
Yeah.
Great. Yeah, thank you so much. Yeah, great. So, yeah.
Oh, I just saw Maulik's chat here. Yeah, and I have never used base plots, so we'll have to learn from you. I'll have to learn from
This
you.
is because the book I am following is using base plots only.
Oh, okay. Yeah. If anybody has favorite topics or favorite chapters in the book, please let me know so that we'll have speakers lined up for like 2 weeks in advance.
Yeah.
So I think chapters 6 and 7 can also follow the same format that Deepti mentioned. Yeah. So
that's true.
If no one else is volunteering, I can do 6 and 7 the week following this week.
Okay, so we can do during the Christmas time. I don't have any plans, so
yeah, me neither.
I can as well do this.
Yeah.
Okay, great. Thank you so much. Thank you so much again.
Yeah.
Sure.
Thank you, everybody. Thanks for doing it.
All right. So see you all next week then.
Yeah.
Yes.
Thank you.
Yeah.
Thank you, everybody.
Thanks.
Have a good
Bye.
day.
Bye.
Yeah.
Bye.